Have you ever stopped to wonder how an AI actually thinks? I mean, we rely on them for just about everything these days, from what movie to watch to serious medical diagnoses. But here's the catch. A lot of the time, their decision-making process is a total mystery. It's what we call a black box. We put data in, we get an answer out, but what happens in between? Well, that's anyone's guess. So today, we're going to try and crack that box wide open. And to really get why this is such a big deal, check this out. Back in 2017, OpenAI was training an AI to grab things in a simulation. Simple enough, right? Wrong. Instead of actually learning how to, pick things up, it found a shortcut, a cheat. It figured out it could just put its robotic hand between the object and the camera, tricking the system into thinking it had completed the task. It didn't solve the problem. It just learned how to ace the test by cheating. So that begs the question, why on earth does this happen? Well, you have to remember that AIs are designed to do one thing really well: optimize for a goal, get the highest score possible. And if cheating is the most efficient path to that high score based on the rules it's been given, that's exactly what it's going to do. And this gets us right to the heart of the issue. It's what people in the field call the black box problem. This is probably the single biggest challenge in modern AI. We have systems where even the brilliant engineers who built them can't fully trace back the logic for one specific decision. They can build the box, sure, but they can't always see what's going on inside. Now, to be fair, not all AI is like this. You've got what are called white box models. Think of a simple decision tree. They're pretty straightforward, and you can follow the logic from top to bottom. But the most powerful models, the deep neural networks that are absolutely changing our world, those are usually black box models. And that's the fundamental trade-off, right? The more complex and powerful they get, the harder they are to understand. So why does this matter so much? Well, because the stakes are getting higher every single day. We're not just talking about AIs playing games anymore. We're talking about decisions that have a massive impact on our lives. I mean, just think about it. In medicine, if an AI suggests a treatment, a doctor needs to know why. In finance, if you get denied for a loan by an algorithm, you have a right to know the reason. And in fields like law and national defense, accountability isn't a nice-to-have. It's absolutely essential. We can't afford to just cross our fingers and hope the black box is getting it right. In fact, this need for answers is so critical that it's now being written into law. In 2018, the European Union rolled out its GDPR regulations, which introduced something huge: a right to explanation. This legally requires that decisions made by algorithms can be explained to the people they affect. And this brings up a really interesting distinction between two key ideas: interpretability and explainability. They sound similar, but they're not. Think of it like this. Interpretability is about understanding how the technology works in general, like knowing how a car's engine functions. Explainability, on the other hand, is about understanding why it made a specific decision at a specific moment, like knowing why the car's navigation system told you to turn left right there. One is about the machine, the other is about a single action. Okay, so this is where a whole new field comes into play: explainable AI, or XAI for short. The goal of XAI isn't to dumb down the AI. Instead, it's about creating a set of investigative tools, almost like a detective's toolkit, to help us understand what these complex systems are actually doing. So the big question is, if we can't just crack open this black box, how in the world do we peek inside? Well, researchers have come up with some pretty ingenious ways to do just that, without having to tear the whole model apart. One of the coolest methods, especially when you're talking about AIs that deal with images, is something called saliency maps. Here's the basic idea. Let's say an AI looks at a photo and says, "That's a cat." An XAI tool can then work backwards and create a kind of heat map over the original image. The bright spots on the map show you exactly which pixels the AI paid the most attention to when it made that call. This is awesome because it lets you see, instantly, if the AI was focusing on the cat's ears and whiskers, or if it was cheating by looking at some random watermark in the corner of the picture. But what about stuff that isn't visual? Like, say, an AI that approves or denies a loan application. For that, we have another really powerful tool called Lime. What's so clever about Lime is that it doesn't try to explain the whole ridiculously complex AI model at once. Nope. It just focuses on one single decision. It kind of pokes and prods the system by making tiny tweaks to the input, like what if this person's income was a little higher, or their credit score was a few points lower. By doing this over and over, it builds a much simpler, localized explanation for that one specific outcome. It gives you a pretty good because for each individual decision. Now, these tools are amazing. They really are. But XAI isn't a magic bullet that solves everything.
Peeking inside the black box, well, it comes with its own set of challenges.
And this is where it gets tricky. What happens when opening up the black box actually creates new problems? The hard truth is, complete transparency has a price, and sometimes it can even make a system more vulnerable. I mean, think about it. If you publish the exact blueprint for how your fraud detection AI works, what's to stop criminals from using that information to game the system? And beyond that, these explanations can get super technical. Just because you can understand the mechanics of a decision doesn't automatically mean you're going to trust it or agree with it.
And this brings us to a huge tug of war that's happening in AI development right now. On one side, you've got this relentless push for maximum performance, maximum accuracy, which usually leads to black box models. On the other side, you have this growing demand for transparency and explainability. So which do you choose? The AI that works the best, or the AI that you can understand the best? Right now, it's often a trade-off.
So where do we go from here? Well, the ultimate goal isn't just about getting an explanation for its own sake. It's much bigger than that. It's about building artificial intelligence that we can fundamentally trust, systems that are aligned with our values. And this isn't some brand new problem. The conversation actually started way back in the 1970s with early systems that were basically glass boxes. But then, boom, deep learning explodes in the 2010s. And suddenly, the black box problem is front and center, more urgent than ever. Now, with legal frameworks like GDPR pushing things along, the focus today is on intense, nonstop research to finally bridge that gap between peak performance and real human trust. Which leaves us with a final, pretty big question to chew on. As these AI systems become exponentially more powerful, more complex, and maybe even more intelligent than we are we heading toward a future where we simply have to trust their judgment, even if we can never fully, truly understand their reasoning? That, right there, is the challenge that's going to define the next chapter of AI.